All right, it is an exciting day indeed. We are on our final unit for this class, Unit 7, and it's another short unit. It only has 3 sections in it. And this unit is going to focus on something called systems of equations, or systems of inequalities. So part of our objectives today is figuring out what do I mean by a system, and then we are going to be looking at different ways in which you can solve systems. And I should also say this first section we're only going to look at linear equations. And remember, linear equations means the highest exponent you will see is a 1. And if these are graphed, they literally make a straight line. So we're going to keep it pretty basic for this opening section of Unit 7. So what do I mean when I say a system of linear equations? Well, a system of equations is 2 equations, and if they're linear equations, they form lines when they're graphed. So the big thing that makes it a system, though, you have 2 or more equations together. If I ask you to find a solution to a system of linear equations, that solution is going to be an ordered pair. And the big thing, in order for it to be a solution to the entire system, that ordered pair has to satisfy both equations. So for example, you look at this lovely picture that I have here. I think I just noticed this. It's a graph of the symptoms of physical illness among college students, and one of the lines represents procrastinators and the other one represents non-procrastinators. That's kind of a dig. If I wanted the solution to this system, if I'm looking at the graph, the answer is literally, where do they intersect? Where are they in the same place at the same time? And it would be right here. So maybe that ordered pair would be 6, comma, I'm going to call that 3.5. That would be a solution to the system because it would work for both lines. Both lines have that point in common. Okay, so to get down this idea of is it a solution or not, it says consider the system below. Determine if each ordered pair is a solution to the system. So this guy is a system. Notice it's made up of 2 equations. That's what makes it a system. And I want to know, does this ordered pair 4, -1, is that an answer or a solution to the entire system? Well, what you need to do is you have to substitute it in for each equation. So remember, this is x and this is y. So 4 plus 2 times -1 equals 2. So that would be 4 minus 2 equals 2. I would get 2 equals 2, so it works in the first equation. Now let's plug it into the bottom equation. So that would become 4 plus 2. I would get 6 equals 6, check. Because the ordered pair works in both equations, we would say yes, it is a solution of the system. Okay, let's try the next one. This time my ordered pair is -4, 3, so if I substitute into the top equation, that would be -4 plus 6. Check, it works out. Now let's check it in the bottom equation. That's a minus. Notice they do not equal each other. So it's a big old for that one. So what we would say, this ordered pair, while it is a solution to the top equation, because it's not also a solution to the bottom equation, overall, it is not a solution to the entire system. It does not work for both equations in the system. Okay, the next thing is something I already touched on a little bit ago. If you're looking at the graphs of the lines, if a system has one solution, that solution is the intersection. So like on this picture, my solution would be right here at 4, -1. That is when they are in the same spot at the same time. So I wonder, what does it mean if you look at the graph and the lines never intersect? What does that mean about the solution? Well, you might already know, but we will address that in a little bit here. Okay, so one of the ways that I want you to be familiar to solve a system if we don't have the graph, if we have the graph, that's easy. We just find where they cross, and that's the answer. If we don't have the graph and we want to solve it, there's two other ways that we can do. One way is called substitution. So in these examples, I want us to solve the system by the substitution method. So, how does the substitution method work? Well, what you want to do is you want to get one of your variables alone. So I don't care which one you get alone. You could get this x alone, or this y alone, or this x alone, or this y alone. I don't care which. Now, me, because I like shortcuts, I like the least amount of work, I will pick the variable to get alone that takes the least amount of work to get alone. So the one that draws my eye, I'm going to get this x alone. Because all I have to do to get that alone is add 2y over. So I would now have x equals -3 plus 2y. And it's alone. Once you have that equation alone, or once you have a variable alone, you want to substitute it into the other equation. So since I got x alone, I want to substitute this in for the x on the other equation. So I'm going to have 5, and then instead of the x, I'm replacing it with my -3 plus 2y, and then my -4y equals 9. So it's the first equation, but I've replaced x with -3 plus 2y. From here, it should be pretty smooth sailing because now I just want to solve. So distribute. Combine like terms. I'm going to add 15 over. And then divide by 6. Okay, now I'm not done because remember my answer is going to be an ordered pair, so I have the y answer. So now the question is, how do I get the x answer? Well, once you have one of them, to get the x answer, I would just plug 4 right back into this guy where we had x alone. So if I plug 4 into that, looks like I get 5. So the final thing I would want you to do is to write your answer as an ordered pair. So my ordered pair solution would be 5, 4. If I were to graph these two lines, that is where they would intersect each other. Be really careful. Every once in a while, I'll see people do all this math correct, and they'll get the answers right, but then at the end, they write their answer wrong. If you write this, that is wrong. In the ordered pair, the x should go first and then the y. Okay, so be careful of that. Let's look at the next one. So again, I want to solve it by substitution. You can get any of the 4 variables alone, but I would pick the one that takes the least amount of work, and the one that catches my eye this time is this y. Because all I have to do to get it alone would be to subtract 2x over. So I would have 1 minus 2x. So now the reason why I got that alone is I am going to substitute it into the other equation. And this time it's going in for y, because it was y equals. So I'm going to have my 3x plus 2, and instead of y, 1 minus 2x. And then my 4. So distribute the 2. I would combine like terms, so 3x and a negative 4x. Subtract 2. And then the last step, I do have to divide by like a negative 1. So if I divide the negative over, x is negative 2. So now that I have that answer, I'm going to substitute it back in, and I would put it into where we had y alone. So y equals 1 minus 2 times negative 2. So that would actually be plus. So I get 5. The last step is to write your solution as an ordered pair. Make sure the x-coordinate is first. So negative 2 comma 5 is the solution of the system. Now on these also, you should be able to double check if you don't think your answer is right. If I take my negative 2, 5 and I substitute it in to both original equations, it better work in both, kind of like what we did here at the beginning. If your ordered pair doesn't work in both equations, then you messed up somewhere. Okay, the other way that you can solve systems, different books call it different things. I prefer to call it elimination. My math lab will call it the addition method. Know that they mean the same thing. I'm going to refer to it as elimination. My math lab will say, oh, use the addition method. This is the method I actually prefer. To me, I'm the quickest at it. If you're doing the elimination or the addition method, your goal is to eliminate something. So on this one, I can eliminate either the x's or the y's. It does not matter. In order to eliminate something, they have to be the same number, but opposite in sign. So I think I'm going to eliminate the y's, and the only reason why I say that, they're already opposite in sign. So if I want the y's to cancel, this top guy would have to be an 8y, because then 8y and negative 8y would cancel if I added them together. So I go, okay, well, I can make that an 8i or 8y if I multiply it by 4. But in math, if I multiply this middle guy by 4, I have to do the entire equation by 4. So we're going to multiply the top equation by 4. It's going to go to all 3 pieces. And I'm leaving the bottom equation alone. So now what we want to do, I want you to think we're going to add our like terms together. These guys cancel when I add them together, and that is the whole purpose of the elimination method. If I add the first 2 sets together, I would have 21x. And if I add the 192 and the negative 24, I would have 168. And now I want to solve for x. So if I divide both sides by 21, I get my first answer of 8. So now the question is, how do I get the y answer? Well, we're going to do it just like what we did on the substitution method. I'm going to take my 8 and I'm going to plug it back into one of the equations. I don't care which one. Let's do the top one. So 3, and instead of x, I'm replacing it with an 8, plus 2y equals 48. So if I simplify, 24 plus 2y equals 48, I would subtract 24 over, and then divide by 2. So my ordered pair solution should be 8, 12. That is the solution to this system. So with elimination, you want to cancel something out, and then it's pretty smooth sailing. Let's look at the next one. So I can either cancel the x's or the y's. I personally, just because I want to show you what happens, let's do the x's. So if I wanted to cancel the x's, notice the top one is a 4x and the bottom one is a 2x. What would I have to give to this bottom guy so that it would cancel with 4x? Hopefully you say we're going to have to give it a -2, because then it would become -4x and then it's going to cancel. So I'm going to leave the top equation alone. But the bottom one, I need to make sure I multiply the -2 to all three. So -4x plus 6y and -14. So now if I combine or add together what's left, first set's gone. I have 11y and -11 when I add 3 plus -14. Divide by 11. So my first answer, y, is -1. So now to get the x answer, you're going to substitute your -1 back in. I'll do the bottom equation. So I'm plugging -1 in for the y. So I get 2x plus 3 equals 7. I would subtract 3. Divide by 2. And I get x equals 2. The last step, write this as an ordered pair. Make sure the x comes first. So my ordered pair solution should be 2, -1. Okay, going back to what I was mentioning earlier, we know if we're looking at the graphs and they intersect, that intersection, that ordered pair, is the answer. Now I asked you, what happens if you graph the two lines and they never intersect? What does that mean about the answer? Well, if they never intersect, that means there is no solution. They are parallel lines. That means they will never be in the same spot at the same time. And what happens, it's hard to see on this picture, but what happens if I graph my two lines and they're the exact same line? They're directly on top of each other. Well, then we would say infinitely many solutions. Every ordered pair is an answer because they would contain every ordered pair. Every ordered pair would work. They are the same exact thing. So I want to end with kind of two oddball examples, and we'll call it good for this lesson. Solve the system. So if I don't tell you a specific way to solve it, it is up to you. So you can decide if you would like to do substitution or if you would like to do elimination. It is up to you. Before I decide which way to do, I kind of look at the system and then I make my choice. So I notice if I look at all four variables, it's going to be kind of a pain in the butt to get one of them alone. So I think on this problem, I'm going to go the elimination route. But substitution would also work. It does not matter. So if I'm going to go the elimination route, I either want to get rid of the x's or the y's. I'm going to say I want to get rid of the x's. So now notice on this one, if I want to cancel the x's, I'm going to have to change both of them. I need to turn them both into a number that will cancel out. What is the smallest number that I could turn 4 and 6 into? And the answer should be 12. So I'm going to give this top guy a 3, because that would turn it into 12. And I'm going to give the bottom one a 2. Now, before we do our multiplying, though, yes, they would both now become 12x's. one of them needs to be a negative 12x, otherwise they're not going to cancel. It doesn't matter which one you give the negative to. Heck, I'll give it to the top guy. So if I distribute, I'd have negative 12x minus 18y equals negative 36. And if we distribute on the bottom one, I would have 12x plus 18y equals 24. So let's start eliminating. So my x's are gone. Ooh, but the y's also go. So I'm left with nothing on the left side. And on the right side, if I add those, I have negative 12. What the heck? If your two sides do not match and the variables are gone, this doesn't make sense. This is no solution. This system has no solution, or you can use this symbol for no solution. Meaning, if I looked at this graph, they would be parallel lines. They would never intersect. They would never be in the same spot at the same time. Okay, and the last one here. I want to solve. So again, it is my choice if I want to do substitution or if I want to do elimination. And to make that choice, I'm going to kind of look at the setup here. So the thing that stands out to me on this one is I already have a variable by itself. So I would definitely go the substitution route. Elimination will still work, it's just going to take more work than the substitution way. So since I already have something alone, I am going to substitute into the other equation. So instead of y, I'm replacing it with 3x minus 2. And now I want to solve. So I'm going to distribute. If I combine like terms, I can see my x's cancel and I'm left with this. If your variables disappear and you are left with the exact same thing on either side, this we would say is infinitely many solutions. So on MyMathLab, they might write this answer a little bit differently, so I want you to be aware. On like a test, I'm fine if you say this and you stop there. On MyMathLab, they might word it a different way. If your answer comes out to infinitely many solutions, here is how they might write the answer. You're going to see that lovely little curly bracket that I can't draw. And then you're going to see the ordered pair x comma y, and then a bar. And then after the bar, they will put one of the two original equations. So they might do this, or they might write the answer like this. And then I'll explain what they mean by this, because it looks crazy. They might use the other equation, which was this guy. It doesn't matter which one. All this fancy notation means is, hey, no matter what numbers I put into my ordered pair for x and y, they will be a solution. Same thing on the bottom. No matter what numbers I put in for x and y, they will be a solution. So it's a fancy way of saying every single thing works. But again, on a test, I'm fine if you just say infinitely many solutions. So one thing that I want you to be familiar with, though, when you're doing the homework, if it asks you to solve it using substitution, please do substitution. If it asks you to use elimination, please do elimination. If it doesn't give you a way, then it's your choice.